Smartphone applications are generally comprised with multiple views or panes. Each pane serves a specific function, such as showing a list of items or showing particular product information. Exploring information with such a multi-pane user interface forces users to frequently switch back and forth between panes, which can be tedious and time-consuming. We propose AirPanes, a novel strategy to structure a mobile interface using panes located in midair around the device. With an m-commerce scenario, we demonstrate how the in-air space could be used to support analytic decision-making tasks which require browsing through large item sets with frequent switching between panes. We next conducted 3 studies to inform our design choices for the AirPanes. We begin our exploration by examining ways to arrange items within the space accessible via the thumb of the hand holding the device. We started with the selection methods and item arrangement styles for the in-air thumb reachable space. We tested 3 selection methods: dwell, keep the finger static for some time; tilt the phone to a certain degree angle; and touch, select by a rapid tap on the screen. We also placed the wedge-shaped items in either 2 or 3 layers. Here is a video showing the tilt selection technique with a 2-layer item arrangement. Our results showed that the 3 selection methods and the 2 arrangements score about equally well. As mobile applications structure their interfaces with multiple panes, we next explore how to offload panes into the around device space. We tested 5 layout styles: stacked layout, where the 4 panes are stacked on top of each other; tiled layout, where 4 panes are squeezed into the space used for a single pane in the stacked layout; tile stacked layout, the 4 panes are grouped in 2 pairs, only 1 pair is accessible at a time. The user can access the other pair by tilting the phone to an angle greater than 45 degrees. Tilt tiled layout, panes are grouped in pairs and a tilt angle is used to switch between pairs. Single thumb layout, the in-air thumb space is divided into 4 approximately equal-sized areas. Moving the thumb into another area triggers the corresponding pane as shown in the video. Here is an example video showing participants selecting an item with stacked layout. Our results suggest that the stacked layout reduces the pane switching time. Based on this knowledge, we next investigate whether AirPanes could facilitate an m-commerce application that supports complex analytic tasks. Such a task simulates a common situation where a user is interested in purchasing a camera from an m-commerce application. With the standard touch version, the user first has to apply filters to shortlist available camera information and then check the item list one by one to get details. While browsing camera information, she can add items to her favorites that match her interests. After browsing through the list, the user can compare the shortlisted items on the favorites to make a final purchase decision. With AirPanes, users move their index finger below the device to access the filters pane. Filters can be applied with the in-air pinch gesture. After applying the filters, they move their index finger to the results pane and start browsing camera detail information. They could add an item to the favorites again with a pinch gesture and continue browsing. After browsing, they move their hand to the resting position and begin using the left thumb to browse information that was stored before. Our results show that the participants were significantly faster with AirPanes compared to the touch technique. Overall, we believe that AirPanes is the first successful step in using in-air spaces for a complete mobile application that pushes the boundary of current in-air interactions.